Yeah, hi everyone. In this video, let us see how we can solve your additional practice one, problem number two. This is about finding CRC, a cyclic redundancy code for the given data word with the divisor, which is represented as a polynomial. That is x raised to the power q plus x raised to the power square 2 plus 1. And we have already seen, so let me just flash the whiteboard. Let's start doing the calculation. So first we need to get the data word and then the polynomial representation of the divisor. So the data word is 111000101. Let me write that first. That is 11100100101. 111000101. Yeah. And then, yeah, this is the data word. And we have the polynomial representation of the divisor. Let's write it as it is. So x to the power 3x squared plus 1. So this we need to represent using a binary. It's very simple. Get the coefficient of these terms, position. So this is x to the power 0. And we don't have x to the power 1. And this we have x to the power 2 and x to the power 3. So we end up getting binary representation as this. Because we don't have x to the power 1, so we don't, that's 0, this 1, 1, and 1. Fine. So now we need to perform the division operation. But before starting the division, okay, because we are trying to divide this with 4 bits in the divisor, we have to add 3, 4 minus 1 number of parity bits. So it is 3 parity bit we will add, and we start the division operation. So because the MSB is 1, so we can divide this by 1 time. So 1 into 1101 is 1101, and modulo subtraction. So the 1 and 1 gets cancelled, so it becomes 0, 1, 1, 0, and then 1, 0, 1, 0, 1, 1. So when you perform to subtraction, this is the result you get it. You're supposed to omit the leading MSB 0, but when you have subsequent 0, you can also omit both of them together. So totally we are omitting 2. So I'll add 1 0 here. And then I need to bring the next 2 bits in the dividend for the next operation. So this quotient, whatever you're writing, whether you are maintaining a track or not, that's not a problem because we are not worried about it. Okay, fine. Now let's go and divide this once again. So we can divide this by 1 time because MSB is 1. So let me just add 1. So 1101. So here all the bit gets turned to 0. Either we can go for the first MSB or all the MSB. So let's just say like we will omit all so that the new 4 bits, let us bring it down. And because we have omitted 1, 2, 3 extra, so the 3 zeros I have to add here. And here 0, 1, 0, 1. If you see the MSB here, it is 0. So you can't divide this by 1, so we divide it by 0. So it means 0 into anything 0, so the 4 bit will be represented as zeros. And now when you do the subtraction, this is 0, 1, 0, 1. So this we will omit because MSB is 0, and after that you have 1, so you can't. So we are omitting 1, so let's bring 1 more bit from the input. Okay, MSB is 1, so we can divide it by 1 time. So 1, 1, 0, 1. So when you take the exclusive OR, this becomes 0, 1, 1, and 1. Okay, let us try to omit this and bring down this particular 0 and add it here. So because the MSB is 1, then we can divide it by one more time. So the result, let us see. Slightly, let me bring it up. Yeah. So 1, 1, it is 0. 1, 1, again it is 0, 1 and 1. Now we left with one MSB, but we can emit the both. And let us bring them down. So you don't have 4 bits, so you only have 3 bits, so we can stop it. So you are getting the CRC as 110. And these are the 3 bits you have to replace with those 0 what you have added initially. So the parity bit initially was added 3 zeros because of the divisor here, and that 110 will be adding it here. If so, then the code word will be 11100 11100, and then 10101 10101. Now those 3 zeros will be replaced with this 110, the remainder part. And this is what is a code word which is generated by the source. And this code word will be sent through the channel, and the receiver will have to check was there any error during the transmission or not. Let's assume this is the code word sent, and this is the same. We also received it. So let's say 1110001. Okay. I hope I have written it properly. Yes. Now, when I try to divide this with the same, see at the receiving side, the received word, if it is this, and then the agreed upon polynomial will be considered for the division, and the polynomial is 1101, and we'll try to divide this again. So when we try to divide, we are getting the remainder 0, then there is no any error, obviously, because we calculated the remainder, and that remainder is added here. If there was no any modification in the bit during the transmission, then the remainder must be 0. So this is what we will be getting it. So let's check. Let's try to evaluate this. Okay, we can, MSB is 1, so we can divide it by 1 time. So 1101. So 1 and 1, these two gets cancelled. So you will get 0, 0, 1 and 1. So you can either go for leaving 1 or 2 at a time. So let's go with 2. 1 extra, so I'll add 1, 0 here. And then let's bring in 2 bits, that is 0, 1. Now this can be, MSB is 1, so it can be divided by 1 time. So 1, 1, 0, 1. So you get 0, 0, 0, 0. All 4 zeros you can avoid all and bring the next 4 bits from the input for the dividend. And here the MSB is 0, so you can't divide it by 1. So we do it by 0. So 0, 0, 0, because 0 into all these will become 0. So that's what we are getting 0. When we do exclusive OR, you get 0, 1, 0, 1. Fine. So let's omit this 0 and bring one more 1 here. So it will become 1, 0, 1, 1. Because MSB is 1, we can divide it by 1 time. So it means 1, 1, 0, 1. So this is 0, and this is 1, and 1, and 0. Okay. Next, so we have 0 here. Let us omit this and then bring one more bit from the input. That's 1. Because this is 1, we can divide it by 1 time. So let me bring 1, 1, 0, 1. And all are 0. And you're left with one more bit, and that is also 0. So at last, when you have all 0, when you keep removing 1, 1, 1, and still you get the remainder as 0. So when at the receiving side, when we calculate, and if you're getting the remainder as 0, then there was no any error in the transmission. But due to some noise exist in the channel, if any of the bit flips, okay, then that will throw an error during while calculating this particular reminder. So this is how the CRC code can be used by both the sender and receiver for error detection. So this code can only be used for error detection. It cannot be used for error correction. Thank you.